All right, let's dive right into one of the most powerful, fundamental ideas in all of programming. We're talking about the loop. It's kind of like the secret engine that powers just about everything in our digital world. But before we even touch any code, let me ask you something. Just think about all those tedious, mind-numbing, repetitive tasks you have to do. What if you could just offload all of that to a computer and know it would be done perfectly every single time? Well, that's the exact problem that loops were invented to solve. Because let's be real, doing things by hand over and over again isn't just boring, it's a recipe for disaster. We humans, we get tired, we get distracted, and we make mistakes. Whether you're just copying and pasting data or checking items off a list, it's so easy for a tiny error to sneak in and mess everything up.
And this is the elegant solution, the loop. At its heart, it's a beautifully simple idea, but it is incredibly powerful. It's a way for us to write a set of instructions just once, and then tell the computer, hey, just repeat this until I tell you to stop. This really brings us to the core of what makes loops so special. They are the ultimate automation engine. They take that messy, error-prone problem of repetition and just solve it cleanly and efficiently. So if we were to put a more formal definition on it, a loop is just a sequence of instructions that keeps on repeating until some condition is met. That's it. Its entire reason for being is to automate repetitive work, which saves us a ton of time and, of course, prevents a lot of headaches.
And here's the really amazing part. Every single loop, no matter how complex it looks, is built on these three simple actions. First, you initialize. You give it a starting point. Then you test. You check a condition to see if you should even keep going. And finally, you update. You take one step closer to your end goal. Initialize, test, update. Seriously, that is the magic formula right there. Okay, so while all loops follow that same basic pattern, they do come in a couple of different flavors, and they're designed for different jobs. And the main difference really boils down to one simple question. Do you know exactly how many times you need to repeat something right from the very beginning? This comparison here makes the difference crystal clear. On the left, you've got definite loops. You know the exact number of repeats. The perfect real-world example is an ATM. It gives you exactly 3 tries to enter your PIN. No more, no less. It's definite. But on the right, you have indefinite loops. You have no idea when they'll stop. Think about logging into a website. It'll let you keep trying until you finally get it right, whether that's on your first attempt or your 50th. So let's zoom in on that first type, the definite loop. Again, the absolute key here is that the number of cycles is fixed. It's known before the loop even starts. You're basically telling the computer, do this exact thing 5 times. Now have a look at how this little bit of code maps perfectly back to our 3 core actions. Int I equals 0. Boom, that's our initialization. We're starting a counter at 0. While I is less than 5, well, that's our test. The loop will only run as long as our counter is less than 5. And finally, I++. That's the update. After each pass, we add 1 to the counter, which gets us 1 step closer to finishing. Now for the other side of the coin, indefinite loops. These are your go-to for situations where the end is unpredictable. The loop just has to keep chugging along until something from the outside world, like, say, a user finally typing the word quit or a sensor detecting a change, tells it to stop. The logic for these is a little bit different. It follows this really clever model, prime, test, prompt. And the most crucial part is that first step, to prime the loop. You have to get the first piece of user input before the loop even begins. Then you can test it. If the loop needs to run, you have to remember to prompt for new input inside the loop. That way, you have something fresh to test on the next go-around. So once you've really got the hang of loops, you can start doing some really powerful stuff, like combining them. This leads us to the idea of nested loops, which is literally putting a loop inside of another loop. And if there is one single golden rule to remember about nested loops, it is this. For every one time the outer loop runs, the inner loop has to complete its entire cycle, from beginning to end. This table shows that idea in action perfectly. Imagine the bold numbers on the left are our outer loop, and the numbers across the top are our inner loop. So for the very first step of the outer loop, when it's at 0, look what happens. The inner loop runs completely through its cycle, 0, 1, 2, and 3. Then, and only then, does the outer loop finally tick over to 1, and the whole process repeats. This is exactly how computers build things like grids, tables, and coordinates. So why does any of this matter? What's the big picture here? Well, it's because once you understand this one concept, you start to realize that loops are truly running almost everything in our digital lives. This quote from our source material just sums up the benefits perfectly. Loops slashes the amount of repetitive code a programmer has to write, which naturally speeds up development. But most importantly, they handle those repetitive tasks with way, way fewer errors than a human ever could.
Just think about it for a second. When a website tells you your password needs a special character, that's a loop validating your input. When you add items to your online shopping cart and the total magically updates, that's a loop accumulating a sum. Every file being processed in a folder, every single frame rendering in a video game, yep, it's all powered by loops.
So I'm going to leave you with this final thought. Now that you've got this new lens to see the world with, take a look around you. From scrolling through your social media feed to watching a streaming video, where can you spot the quiet, powerful work of a loop happening right in front of you? I think you might be surprised by just how often you find it.